we can take a more mindful approach to software architecture. And we're going to dive into that. And thank you for the introduction, by the way. Yes, my name is Micheal Carducci. I'm an independent hands-on software architect. I'm author of that book, and I've done a variety of different things. And just to kind of set expectations a little bit, so much of software architecture is focused narrowly on one particular area, or they take a very abstract or oversimplified look. And by simplistic, I don't mean simple. I don't think there's anything in architecture that is simple. I think they look too narrowly at theory in a way that doesn't always prepare one for reality. And I remember in college, I took a course on applied mathematics. And if you have ever done this, you know in those textbooks, we always have light, inextensible strings threaded through perfect pulleys, and we're always operating on a frictionless plane. And there's a danger, though, in being too academic. What I've learned is that too often academics aren't interested in what works in practice until they've proven that it works in theory. And that was why Venkat in the keynote this morning took offense at being referred to as an academic. So approach this with an open mind, I think, but because it's easy to tune out the things that are familiar. But I want to take the things that are familiar and show them to you in a new light. If there's one thing that I've learned from my experience as a magician, is that when you change the way you look at things that you look at change. But you're all going to be better and more effective architects by the end of this session, myself included. And it starts with this idea. Although, everything in my applied mathematics book took place in a vacuum, software architecture cannot exist in a vacuum. It does not operate on frictionless planes. There are no perfect pulleys. There are no light, inextensible strings. We operate in reality with fallible humans and imperfect technologies. Architecture has to connect diverse, abstract ideas and all these different fragments and apply them in the messy reality that we live in. And I think we are overdue for a model of software architecture that takes into account reality. So my goal for this session is no matter where you are in your journey in technology, I want to arm you with everything you need to know to be more effective. Basically want to move you up in the Dreyfus skill acquisition model. So this is a model of how we learn. We start as a novice. We don't know anything. And we operate in very constrained ways. We follow recipes. And a lot of architecture is focused on recipes. Oh, well, we have this pattern and that pattern and that pattern. And they tell you, do this, do this, do this, do this. This isn't how we can approach architecture. Because with architecture, we have to think contextually. This is why I think architecture is more important now than ever, because we have models that can generate code, but they can't operate in a meaningful enough context yet. This is what we add. This is the human element that we add. Too often in architecture as well, we think about this idea of silver bullets, these magic solutions that will work for everything. That anybody who says they have a silver bullet is selling you something. In fact, there's this idea of silver bullets has its roots with Fred Brooks, very towering intellect, very influential guy. He has an amazing essay called No Silver Bullets, Accident and Essence in Software. Definitely worth a read if you get a chance. I first learned about that paper, that very influential paper. I think it won a Turing Award when I started looking at the work of Dr. Roy Fielding, who is most famous for his work on REST, but he was one of the architects of the World Wide Web. And I think that's a phenomenal case study of what you can accomplish when you think about software architecture contextually. And he said this. He said, some architectural styles are often portrayed as silver bullet solutions for all forms of software. However, a good designer should select a style that matches the needs of a particular problem being solved. And so what that means is we can't operate down here as architects. We want to work our way up into the proficient or expert levels where we can make more mindful decisions. In other words, the patterns that exist in software architecture are just examples of architectures that have worked in the past. And if you look at a lot of the state-of-the-art literature on software architecture, they focus very heavily on these types of patterns or these topologies. And to some people, this is architecture. This is not architecture. This is a side effect of architecture. These are just things that we've done in the past in certain contexts that have proven to work within those certain contexts. But they will not work, they will not be valuable or useful to you if you're not in the exact same context as them, and you never are. What's worse is we tend to try to classify these things. We tend to organize these like, oh yeah, layered monolith, that's super simple. Anybody can do it. That must be a beginner level. And we look at it the wrong way. We think, oh, these are the beginners, these are the intermediate, these are the advanced. And I'm a senior architect, or I'm the chief architect. I've had that title in my career. When they said, Michael, we want you to be our chief architect, I thought, okay, getting some recognition. I thought it sounded fancy AF, but in reality, it just meant that I had 3 times as many meetings to go to. Or another way that we regrettably classify architectures is, oh, yeah, these are the ones that scale, these are the ones that don't scale, which is another reductive, simplistic way to think about software architecture. But honestly, one-dimensional thinking is at odds with being effective as a software architect. This is beginner-level thinking. Maybe an advanced beginner, but it's still a beginner. And what's worse is as we make progress, it is very easy to fool ourselves once we get to this level of advanced beginner and we know all the patterns and we know the recipes and we know how to follow them, that we don't advance from advanced beginner to competent. And instead we branch off. We assume that we've already mastered this. We assume that we're already experts. And as soon as we do that, we lock ourselves. We become an expert beginner. This is a fantastic write-up of the title of this essay is How Developers Stop Learning, The Rise of the Expert Beginner. Definitely worth reading about this. But it's time to stop thinking about architecture as recipes. And there's another challenge that I've run into. One of my good friends, longtime friend, is speaking here at the conference, Mark Richards, and he wrote a book with Neil Ford, one of my favorite books to this day, Fundamentals of Software Architecture. They have a second edition. If it's not coming out soon, it's already out. And they gave us a really useful rubric for evaluating architecture styles. And they gave star ratings connecting different architectures to meaningful abilities, architectural capabilities of key interest. But I want to give you the tools to become more effective software architects. And in order to do that, we have to realize that holistic architecture is more than just facts and patterns. And I want to give you a quick example of what I mean by that. I'm going to give you some knowledge. I'm going to show you how you can cap out very quickly. More than facts. I've got 2 jars that are not labeled. One is 29 ounces, one is 3 ounces. And if the goal is to get exactly 23 ounces, we can fill up jar A, and we can take out 3 ounces twice we could fill jar B twice to subtract 6 ounces. So here, I want you to measure exactly 100 ounces of liquid, or milliliters, or whatever your preferred unit is. I live in America where, regrettably, we still haven't discovered more useful, we haven't discovered the metric system yet. In fact, I went to school in the UK, and when I was studying physics, on the first day of my class, I was in a physics class, they gave us a general knowledge test. And they said, Michael, or they just asked us a bunch of questions. And one of the questions was, what's the speed of light? And I wrote down the speed of light in miles per second. And he marked it wrong. And so I threw a big fit. And I said, that is right. I demand you mark that right. He said, it might be, but we use SI units here. And I said, well, it's still right. You shouldn't have marked it wrong. And he said, you know what, Michael? You can use whatever units you want. And so here I am using foot-pounds and all these other stupid units that we've used out of inertia, not out of thinking about the problem. It's just, this is what I'm familiar with. And while everybody's just moving the decimal point around and doing really simple mathematics, I'm dividing by 12 and multiplying by 64 and dividing by 5,280, really convoluted mathematics. And I quickly realized, oh, this entire system of measure is stupid. Either way, I digress. 100 ounces. How do we do that? Well, we have jar A holds 21 ounces. Jar B holds 127 ounces. Jar 3 holds 3 ounces. Well, this is really easy. I fill up jar B, 127 ounces, and I subtract the 21. And so now I have 106 ounces in that jar, and then I use jar C twice to subtract 3 ounces twice. That gets me to 100, right? There's the answer. Fill jar B, subtract jar A, subtract jar C, subtract jar C. Easy. Here's another one. We want to measure exactly 99 ounces. Anybody want to hazard a guess? Yep. Go ahead.
Okay.
Yeah, I can see you're thinking about it.
I mean, copy with the that with the like. Okay.
14, yep. So if we subtract 14, that'd be 149. And then we take 25 out again.
Right.
Yep.
And then,
That's 99.
Yeah.
You're absolutely right. Here's another one. We'll measure exactly 5 ounces. So you're doing the math. I can see the wheels turning. We can fill up jar B, subtract jar A, 18 ounces, subtract 10. We're at 5. Here's another one, 21 ounces. You're getting good at this. You are advanced, sir. We want to get 21 ounces, so we can take 42 minus 9 is 33, minus 6, minus 6. Yeah. And we're right there. And we can do this again and again and again and again. You're getting the hang of this, right? Here's the last one. Measure exactly 25 ounces. How would you do it? Yes. So this is a famous experiment called the water jars experiment. It's a psychological experiment. And they gave this test to people. And it was just like the test I gave you, where there are a bunch of questions where you follow the steps. You follow the algorithm. Jar B, minus jar A, minus jar C, minus jar C. And people got so used to that when they got to this question, which to some of you was absolutely obvious, nobody could do it. And then when you finally said, oh yeah, you just take this minus that and you ignore this third one because it doesn't matter at all, they got so mad, it flipped the table. I was reading the write-up of this study. One guy, apparently, this was the language he used, became extremely distressed when he saw how simple the solution was. Because he found something that worked and he followed it again and again until it didn't work anymore. And we lost our ability to think critically. Now, one of the things I've realized being a software architect is that when you are a developer, the most important thing that you can invest in is your known knowns, the things that we know that we know. And we find a set of things that we can follow and use over and over again. But moving into an architect role, our depth starts to matter less, and our breadth starts to matter more. And so there's a shift that takes place. And what we have to do is we have to give up some of our depth. This is an architectural trade-off. This is the architect's trade-off. We relinquish some of our depth so we can start to build some breadth. And a lot of this is the stuff that we begin to know that we don't know. So you're starting to making a deliberate choice to move unknown unknowns into the known unknowns. Because as soon as you know what you don't know, you can formulate the right question to ask. And there's a famous quote by Albert Einstein, supposedly. He may or may not have said it. We like to attribute a lot of things to smart people, in history. But he said that if I had an hour to solve a problem and my life depended on it, I would spend 55 minutes trying to figure out the right question to ask and only 5 minutes focusing on the answer, because when you know the question to ask, the answer becomes self-evident. I got asked a lateral thinking question once in a job interview. Have you ever had this happen to you? You do a job interview and they start asking you stupid questions that have nothing to do with your actual job. The question I got asked, and in fact, me and 3 friends of mine, we were all applying for the same job, which was already stressful. That already creates friction in the friend group because I think they had one position. And the first guy did the interview. He said, it went pretty well. I said, how'd it go? He said, went pretty well, but they asked me a question and I couldn't answer it. And I said, oh, what was the question? He said, I'm not going to tell you. That's your job to figure it out. I finally found out what the question was. The question was, you are in a room and you are in a room and there are 3 light switches. The door is shut. And those 3 light switches control 3 light bulbs. Each switch controls 1 light bulb. And your job, without opening the door, once you open the door, you can't touch the switches anymore. You have to figure out which light bulb controls which switch. And everybody in my friend group got stumped. And in fact, most of the people who were interviewed got stumped. But I took the approach of trying to figure out what the right question was. And afterwards, he's like, so how'd you do with the light bulb question? And I said, I got it. What do you mean you got it? You must have Googled it. You must have heard that question before. I said, no. I said, I realized that the important question was, how can a light bulb have a third state?
Okay.
Because there's an on state and an off state. But if I'm going to connect light bulbs to switches, I need a third state. So I gave them 2 solutions. One solution was, how much time do I have to figure this out? They said, as much as you need. I said, great, I'm going to turn one on, and then I'm going to come back in 10 years. And then I'm going to turn it off again, and then I'll turn one of the other ones on. And then I have one that's on, one that's off, and one that's burned out. And then I said, but you know what? I don't have to wait 10 years. I'm going to turn one, leave it on for 10 minutes. This is before everything was LED. And then I'm going to turn it off. I'm going to turn a second one on, and I'm going to have one that's off but hot, one that's off but cold, and one that's on. But as soon as you know the question to ask, the answers often become obvious to us. And so a lot of architecture is figuring out the right questions to ask. But the thing is, to find those answers, you have to know what you don't know. So this is kind of the evolution of the architect, because there's no academic path to becoming an architect. There's no like software architect, at least. I mean, you can go to school for architecture, like useful architecture. But it's a process of evolution. And as we are making our way through here, oh yeah, that's what I was looking for. It's a process of evolution. And the thing is, the leap between senior developer and architect is a large one because the scope changes, and it changes in a really radical way. We need new tools and new mental models. And we're in a field now as architects where there are no best practices. In fact, Mark Richards and Neil Ford codified this as their first law of software architecture, that there are no best practices, there are only trade-offs. And they originally wanted lots and lots of these laws, like 10 commandments of software architecture, or the 6 golden rules, or the six ironclad laws of software architecture. And for the longest time, because I was with them as they were developing this, they had one. Everything is a trade-off. And sometimes I'd be sitting where you're sitting, and they would say this, and somebody in the room would say, but what about this? What about this? There's no trade-off there. That's only good. And then Mark or Neil would patiently explain all the trade-offs they hadn't considered. And so they added a corollary to the first law of software architecture, that if you think you've identified something that's not a trade-off, it is. You just haven't identified the trade-off yet. And but there are no best practices. There's no good architecture versus bad architecture. We're just dealing with trade-offs. And I remember having a conversation with a developer friend of mine, and he said, you know what, I'm glad I'm not a software architect. I like being in a field where there are absolute right answers. And I wish it were that simple. So how do we make this leap? How do we make this evolutionary leap? And the very simple answer is more thinking, less typing and more thinking. And in other words, to be effective, We have to think more deeply about the problem. To be effective, we need to be aligned on goals and purpose, because architecture is not something that exists in a vacuum. We need to be able to see multiple possibilities, as Venkat said in the keynote this morning. We need to be able to entertain an idea without accepting the idea. We need to look at those possibilities and identify the subjective right possibility, because there are no objective right answers. There are no objective best possibilities in every piece of software. There are only subjectively optimum options. So we have to identify the right possibility. There's a very short range on my remote, so I'm going to keep standing over here. We need to be vigilant against the wrong possibilities. We need to be able to then design and communicate the right architecture. We need to be able to build this architecture that meets the needs of the present and the reality of the present with an eye towards the future. And we need the human and interpersonal skills to drive technical and organizational change. So if we're moving up through these levels of expertise to this level of expert, there is a lot of skills that we have to develop. From being a business analyst to being a communicator, to being a writer, a designer, an innovator, a change agent, a politician, a creative thinker. We have to have that broad technical knowledge. We have to have diverse mental models to draw on to think about different problems in different contexts. And there's a whole bunch of other soft skills. Architecture is about navigating complexity and nuance. So I like this. This is called the Cynefin framework. The Cynefin framework, it's a Welsh word, I think. It's spelled with a Y, and the Y is not where you think it would be. I think it's Cynefin. And what the Cynefin framework teaches us is that in different problem domains, different processes matter. And in the clear domain, there are best practices that we can follow. And so we look at it, we figure out which problem it is, and then we respond. But then as we move into the complicated domain, we will look at the problem, we'll think about the problem, then respond. This is where we're following more good practices. But then as we cross over to the complex domain, this is where there may not be a lot of prior art that we can benefit from. So we've got to probe, we've got to probe the problem, we've got to sense, and then we can respond. This is where emergent practices come out. And then the last one is the chaotic domain, which happens in software from time to time. But again, we need different approaches. And this is why I think this is a particularly valuable skill to be investing your time and effort in right now, because what we've learned is AI models operate extremely well here. They do okay here. They really start to fall apart here. And this is where most problem domains reside today. So they can help us. We can break the problem down into a bunch of these clear domains and delegate certain activities to the AI, but we need to be in that driver's seat. So this changes how we operate, but it's also valuable. And I love this quote from, I think it's 99 Things Every Software Architect Should Know. You don't drive the architecture, the requirements do. You do your best to serve their needs. So evolving from a developer to an architect changes the way we look at problems. We have to look at problems from the perspective of the business. And this was a hard thing for me to begin to understand in my career, because it does change the way we look at solutions. So what is architecture? It's everything the software can do beyond the defined features and functions. And what is the everything else? Because normally if you're on a software project, you've got a product owner or somebody in a similar role who says, okay, we're building this app, it has to do this and this and this and this and this. Okay. Well, it turns out there's a near infinite number of ways we can write code to deliver a set of features and functions. And sure, some of them might be more efficient in terms of time or space complexity. But what's that everything else? It's these things that I like to refer to as capabilities. These have a lot of names. Sometimes we call them ilities. Sometimes we call them non-functional requirements, architectural characteristics, system quality attributes. I like the term capabilities because my goal as an architect is to be able to communicate with the business people. And when I start talking about non-functional requirements, they tune out. They turn off. They're not interested. They're interested in the functions. And so when I think about capabilities, it's easier for them to wrap their head around what we're talking about. And these capabilities, these abilities, these are the language of the software architect. And the thing is, there's a lot of these. This is a list from a Wikipedia article under system quality attributes. There's a whole lot of these. Now, we can narrow these down. We can narrow these down to maybe a set of capabilities of key interest. Performance, scalability, elasticity, evolvability, right? A lot of these are more interesting. And when we look at these patterns, what are the capabilities of these patterns? We know microservices scale. We know monoliths don't, right? Not necessarily. You can scale all of these, but the degree of scalability is what we're really talking about. You can scale a monolith. Facebook famously decided they didn't want to decompose Facebook. They decided they were going to double down on scaling the monolith for a long time. Facebook, for a very long time, was a gigantic PHP monolith, and they became worth billions. So we can do these things, but some of them are more suited than others. And this line of thinking, as a result, is anathema to good, thoughtful architecture. And the same with this. We can scale monoliths. And the thing is, this black and white thinking ignores the importance of architectural fit. This is what we are trying to accomplish. We're trying to deliver an architectural solution that fits. And this is why I have this metaphor of the tailoring form, the suit, the way that a good suit can fit. And this suit used to fit me, but if I button it now, life happens. But then I can tailor it. So this is why the model itself that I'm talking about is called the Tailor-Made Architectural Model. And like I said, that's something we talk about in the book, but it's an open source model as well that gives you more useful tools to think about software architecture. Because fit matters in a lot of dimensions. Like, this is a suit that might fit me well, or maybe fit me well a couple months ago, but it doesn't just have to fit my body in the same way your architecture doesn't just have to fit the business problems we want to solve. This is a linen suit. It's very light. It is very breathable. Mark Richards is wearing a wool jacket that is much heavier, and he is suffering right now because it turns out it is hot in South India. So it might fit his body, and it fits his body extremely well, but it doesn't fit the climate of where he's wearing it. And you can buy a suit that might fit really well and fit the climate, but it might not fit the environment that you're in. If it's a black tie dinner and I show up in my wrinkled linen suit, everybody's got to look at me like, did you not get the memo? Did you not realize where you were going? So this fit has to fit on a lot of dimensions, and the same with architecture. And architecture that doesn't fit, no matter how clever it is, no matter how expert it is, no matter how scalable it is, if it doesn't fit, it's not the right architecture. As Mark Richards is fond of saying, if you don't have the right architecture in place, or you choose the wrong architecture for a given project, generally the functionality might work, but the application as a whole won't be a success. So we're not just trying to max out as many of these capabilities as we can, we're trying to figure out the dimensions of fit. So we have to think about how we answer those questions, how we define these things. Now, a guy named Simon Sinek wrote a great book called Start With Why. And it's a leadership book, and it's talking about motivating people and everything else. But as a general principle, this idea of starting with why is extremely valuable. He points out that he gives us the golden circle. On the surface is the what. Just beneath the surface is the how. But at the heart of everything is the why. Why are we doing this? We need to do more than just attempting to follow best practices. Holistic architecture is driven by the why. So I'm going to give you today my architectural analysis process. I'm going to take you through the steps. The first one, because if you want a precision fit, you need to take precision measurements. It's as simple as that. And the first one is before we have the conversation with the business, we have to prepare. I don't want to just jump into conversation with the business.
Yeah.
I want to start moving some unknown unknowns into the known knowns and the known unknowns and the known knowns. We have to chip away at these unknown unknowns. So I start with foundational questions in mind. What is the business domain? Because we can't think about the value that we're creating as existing entirely within the computer or the data center or the cloud or anything else. The solution lives in the computer. The problem is always outside of it. The problem fundamentally is always outside of it. So what does that problem domain look like? Who's the customer? Who's the user? These are not the same thing. I was having a good conversation with somebody about that just before I came down here. What does the customer or the user's business domain look? What does a workday typically look like? Where are their pain points? How is this system going to make their lives better? Because ultimately, software always serves people. And if you want to be effective, whether you're a developer or an architect or anything in between, you want to be able to understand how the software you're building is going to improve somebody's life. Whether it's an API or an app or anything else, there's always a human in there somewhere. So the next thing I'm going to do is I'm going to locate documentation, because a lot of these projects, somebody's already articulated a vision. There are pitch decks and everything else. There's all of these different things. So you got to find these. I'm going to study them. And then I'm going to try to articulate my understanding. I'm actually going to write something up. And this is really, for me, I could, of course, just give all of this to ChatGPT or your favorite model and say, summarize this for me. But that's not the goal. The goal is not to get a summary. The goal is to think through. And writing is an active thinking process. I love this quote. If you're not writing, you're not thinking. And this is why I'm very careful about where I use generative AI. In other words, where it's just doing labor for me and using it for things like that, and not using generative AI to delegate my thinking. This is my value proposition as a human being in the economy. Is as a knowledge worker, as a thought worker, this is what I'm trying to do. So I don't want to delegate my thought to a machine that's not outstanding at it. Second thing I'm going to do is I'm going to identify the business stakeholders. Who do we need to talk with? Who do we need to align with? Who do we need to get buy-in from? And this leads us to one of the axioms of this model, that designing an architecture is more than understanding the business vision, it's executing on that vision. So you might perfectly understand the business vision, you might have a perfect plan for the architecture, but if you can't execute it effectively, the entire thing is moot. We need to be organizational change agents. And there are 5 things you need to affect change. You need authority, accountability, responsibility, knowledge, and will. And guess what? None of us have all 5 of those in our organization. But that's going to be instructive in terms of who you're going to invite to these early conversations. Now, when you're identifying these stakeholders, try to keep it smaller if possible, because that's going to avoid a lot of wasting time and arguments and things like that. Then you're going to go in and have the first meeting. You're going to invite the key stakeholders, and the goal of this meeting is to build trust and alignment. You want to foster an atmosphere of cooperation and collaboration. The agenda that I generally take: introduction and roles. We try to align on the vision, and then I try to give questions and clarifications where necessary. So in terms of the introductions, it's have everybody introduce themselves, what they are in the project. Architecture goes last, because our goal is to support them and help them deliver on this vision. So this is one of the reasons we always go last. And when it comes to architecture, I say something like this: my name is Micheal Carducci, and I am an architect on this project. We've got a clear backlog of features to deliver. My job is to think about the best way to deliver these features to minimize risk and maximize our chance of success. There's a near infinite number of ways to write software to deliver features, and I want to ensure we choose the optimum path for the present and for the future of this project. Before we get too far, I want to validate our vision and understanding are aligned. And this is where I'm going to lay out a short version of what I think this project is going to be. And this is my first chance to get feedback on this because I want to make sure we're on the same page. I want to orient the entire relationship between the business and architecture and development leadership as one of collaboration, one of cooperation. And so this is, a lot of times the way I go about this is I let the business pitch what their vision is. And usually they've got some kind of pithy one-liner is, this is the X of Y. This is the Uber of blah, blah, blah. Or this is the TurboTax of blah, blah, blah. But your job here, you want to probe deeper. Okay. I love it. So I'm an XYZ and version 1 of the software launches. What does this mean to me? And try to answer the question. You'd be surprised, by the way, how often they haven't thought that far ahead. They just got so many pats on the back on their pithy one-liner that this is a real conversation discovery. And the thing is, listen actively, take notes, right? Annotate your architecture vision document. And then I'm going to give the architecture pitch back. Okay, let's make sure I understand the vision. Now, the key thing here, don't get too far in the weeds. Be business and value focused, not technically focused, because a lot of these are non-business, non-technical people. If you get any feedback or interjections, pause, listen, make notes every time somebody interjects. And then the last part here is, what else do I need to know for success? So these are any open questions that you've identified. Important things to align on are the immediate scope and the goals. Are we building an MVC or a proof of concept? What does the business hope to achieve with the first release of the system or a modernized system if you're dealing with a legacy system? So pay attention to the stakeholder and friction pain points. Figure out what keeps them up at night, as it were. What are the things that give them anxiety? Listen with empathy and note who and what. This is going to be really valuable later because what you're doing is you're borrowing authority from these people. So later on as an architect, if there's anybody pushing back, it's not, well, architecture says you have to do it this way. It's you're connecting it back to that stakeholder and their goals. And say, well, if you want to do it a different way, take it up with them. I don't have the authority to do that. You don't have the authority to do that. But I hear what you're saying, and let me know how that conversation goes. You can say it nicely or not. That's up to you. I try to say things nicely because cooperation is important. Now, when you're in this meeting, this is not the time for solutioning. If you have ideas for solutions, write them down, but keep them to yourself. Ask business value questions based on the potential solutions, though. This is a good way to check your assumptions. The only place that the solutions stuff matters is maybe you're trying to identify the boundaries. Like, is this going to run on cloud or on premise? Are there restrictions on the use of open source software, things like that? Is there a target operating system or a budget that we have to stay within? And then at the end, I like asking questions like this. What is the first release going to look like? What about in 3 years? What about in 5 years? What about 10 years? Also, do we want to go fast now or do we want to be able to go fast in the future? That's another trade-off that most people don't realize is a trade-off. And then from there, I'm going to identify architectural capabilities. And I'm going to try to write these out. And again, I want to connect capabilities to specific highlights or moments from those meetings. I want to connect to stakeholders. Think about things that are not going to be in the business vision document. They're not going to talk about fault tolerance usually. They're not going to talk about security usually. And so then I try to write a non-technical business value focused paragraph referencing these capabilities. But then we have to prioritize because we saw that giant list of abilities. But they can't have them all because every time you make one of these stronger, you're making something else weaker. So try yourself first to figure out what you think the priorities are. This is another good way to check your assumptions. This is really a tool to align on visions. And you might be wrong here or there, but that's okay. It's a learning opportunity. And then the next thing is I'm going to have another meeting to qualify and quantify and validate these capabilities with the stakeholders. So it's another similar meeting. Meetings, chief architect, nothing but meetings. So same thing, further alignment, review the architecture requirements. And what I'm trying to tease out of all of these ilities, what are the ones that are business critical? And because the business criticals are the ones that we have very little flex on. And these are where we're going to have to navigate trade-offs. And the last one is the next step is I'm going to document and score these capabilities. And I've got a system for that. Right, on a scale of 1 to 5, actually, I've changed this a little bit now that I'm looking at this slide. But we want to figure out where these need to be. But now we have an idea of the capabilities, the ilities of the system. And now we have to design an architecture that's going to give us these. This is where things start getting tricky, and this is where the current status quo of architecture is letting us down. Here's a question for you. Where do the architectural ilities come from? What is it about a system that is scalable or not scalable? Where does scalability come from? Where does yes, you're right. You could throw money at it. You could throw money at almost any problem. You're absolutely right. What about modifiability? Where does that come from? Right, we have all of these ilities. We had that whole list of them. In fact, I'm going to jump back just for funsies. I'm going to find this giant list here. Where does elasticity come from? Where does composability come? Where does testability come from? Where does interoperability come from as an ility? Because right now we typically think of these as attributes of these patterns, but it's not these patterns that make all of this stuff appear. They actually, the capabilities actually come from constraints. We're constraining the degrees of freedom in the building of this system. And essentially, every single time we make an architectural decree to constrain the degrees of freedom, what we are essentially doing is we are making an architecturally significant decision. How components communicate, what the component granularity is, how the module boundaries are being defined, things like that. And when you think about these constraints, you end up with atomic building blocks for defining architectures. And there's a great paper in 2016 called Software Architecture Constraint Reuse by Composition. And the author says, constraints can serve as documentation to better understand the existing architecture description, or can serve as invariants that can be checked after the application after the application of an architecture change to see whether design rules still hold. In Dr. Fielding's dissertation, he shows since properties are created by the application of architectural constraints, it is possible to evaluate and compare different architectural designs by identifying the constraints within each architecture, evaluating a set of properties induced by each constraint, and by comparing the cumulative properties of the design to those properties required of the application. So constraints are a really powerful mechanism for not only designing an architecture and documenting an architecture and evaluating an architecture, but these are reusable components that can be combined in different ways to get different architectures. Now, the key thing is, like I mentioned earlier, fit applies on a number of different dimensions. And so not only do we have to think about those architecture constraints and the ilities that they induce, but we also have to think about the reality that we're in, because we have non-architectural constraints that constrain us, the teams that we're interacting with, the organization that we're all inside of, and the environment that we're building. So to reduce risk, we have to consider these additional constraints. What are these? Well, in the team itself, there's the skill and maturity of the team. And I don't mean they're skilled or not skilled. I've always worked with skilled teams, but do they have the right skills to deliver the architecture that you're proposing? Do they have a process that is mature enough to support that architecture? Things like automation. Where are we in our journey of automation? Something like microservices requires an enormous amount of automation to make work. And if the teams don't possess that skill or we haven't built automation into it, you're going to have challenges. We have priorities, we have hierarchies that we all have to navigate. Architecture usually can't override other business priorities. That's a problem. That's why we have to have those meetings to build that alignment. In the organization, we have to think about things like budget, like timeline. Does the organization have well-defined domains or not? Have we done the work of DDD? That will depend on whether or not we can adopt domain partitioned architectures or not. Also, if we have an organization structure that is compatible with an architectural structure. And the environments, we have to think about the complexity of the solution space, the sway and influence we have in the organization, the maturity of our infrastructure, the deployment maturity, the organization's openness to new ideas if we're asking them to change the way they work. And do we have autonomous development environments? That's going to open or close certain doors. So now that we kind of have this idea in practice, I'm going to give you these patterns that we've talked about in the abstract. And you can see something simple like the layered monolith. These are the defining constraints. And what's interesting is because this is such a simple architecture, there's not very much that it demands of your teams or your organizations. But what this model does is it takes all of these constraints and connects them to what it's going to demand of the team and the organization. So we look at something like the distributed end-tier abstract style. Suddenly, now that we have a distributed system, that requires the environment to be a certain way. We have independent deployability. This requires a great deal more. If we look at some of these other ones, the modular monolith, this is microservices deliberately put into a monolith to bring simplicity up and cost down. But we need well-defined domains. We need domain-aligned teams. And we need that domain partitioning. We need to figure out how to partition the database itself. And so every single one of these, as we go through them, you start to see that every constraint has dependencies, whether we're doing choreographed architecture, event-driven architecture, or the microkernel architecture. And one of the tools, this is part of the open source kit, this is the prototype version of a workspace where you can define these goals and we can try different candidate architectures and see how they align to our targets. Now, we need to be mindful to make sure that that we're trying to get enough of an architecture, of an architectural capability rather than a lot. And it's a good way to look at the trade-offs because like I said before, every time you increase something, you are taking away another ability somewhere else. There's always a trade-off in there. And so the model actually gives us what all of these different constraints are and all of the different areas that they are improving or decreasing certain architectural abilities. And when you've come up with a candidate architecture defined by the core architecturally significant decisions, the constraints, when you have a set of those constraints, you have what is called an architectural style, and is a named coordinated set of architectural constraints. Roy Fielding talks about this in his 2000 paper, Architectural Styles and the Design of Network-Based Architectures. And it was introduced in 1992 in a book by Perry and Wolf. It's a well-established idea, but this is a fantastic thing because when you've got a group of people who all, who've seen different things that are called microservices. Well, let me put it this way. How many people in your organizations right now, by show of hands or whatever, how many of you are in an agile organization? Yeah, for whatever that means. But I guarantee you, every organization has a different definition of agile. How many people are working with microservices? Okay, quite a few of you. And every single one of you has a different definition of what microservices means. Because I guarantee you, unless you're working on the exact same system in the exact same place, your architectural constraints are different. And this is dangerous because you do this enough and you get stuck in that expert beginner loop because you're like, oh yeah, I've done microservices at my last 5 jobs. And you're doing it the same way, even though everything is different in every different job, or most of the things are different, or something is always different. And so we end up with these really reductive definitions of things like microservices. And then you, as an architect, you go to tell the development teams, okay, we're building microservices. And they say, got it. And they're all picturing something different. So I want to wrap this up. We've got 8 minutes left. Is that about right? So I want to wrap this up, but I will say this. So this paper, how many people actually read Architectural Styles and the Design of Network-Based Architectures by Ray Fielding? I know some people have, because this paper is most famous for where he introduced REST. And so a lot of people have read it because they wanted to understand REST better. So they got the paper and they skipped directly to chapter 5, because chapter 5 is where he starts talking about REST. But that paper wasn't about REST. That paper is about what we're talking about here, design by constraint, and what a powerful model of architecture it is. So that was a big influence for me in writing that book and developing this model, and we just took it and took it further. So let's kind of boil all of this down. The Tailor-Made Architectural Model, it's an integrated, holistic approach to software architecture. It moves beyond the rigid patterns towards a customizable, evolvable architecture, and it emphasizes this idea of design by constraint. And like I said before, it's not a new idea. The earliest that I've seen people talk about constraints in software is going all the way back to 1975 in Fred Brooks' The Mythical Man Month. Foundations for the Study of Architecture by Perry and Wolf in 1992 did a great deal of effort. They really focused on this idea. We saw it again in parts in 1996. We saw it in Fielding's paper. We saw it in that other paper I quoted, and we see it in the book Mastering Software Architecture. What we did in Mastering Software Architecture, other than connecting the constraints to what it's going to require of the organization so we can manage our architectural risk, because this is a really key thing. If you overprescribe architecture, or you try to prescribe an architecture that the organization can't support, it's going to fail. And I've done it. I've failed a bunch of times as an architect. And failures are not bad, because that's how we learn, if we learn. And that's why it's so important to do these retrospectives from time to time. But so I took these ideas and built on them. I can't take credit for anything really, but I built on them, connecting each constraint to the dependencies in the organization, the teams, and the environment. And these are questions, whether you read the book or whether you follow the model or not, these are questions we have to ask to manage architectural risk. And the other thing that I did, I built on the work of Mark Richards and Neil Ford to actually start to weight these architectural constraints by how much they move up or down a certain certainty. That's a super useful thing because it gives us design time feedback. So the core concepts in this model for holistic software architecture, to solve the whole problem, as it were, we use architectural design by constraint. These constraints are clearly defining the trade-offs with numeric weights, and it reduces a lot of the trial and error, because historically so much of software architecture is we're going to build it, we're going to deploy it, and then we're going to see how it works. The best way that I've heard this summarized is a quote, I forget who said it, but the quote is, "Software and cathedrals are very much the same. First we build them, then we pray." And I think we can do better. I think architecture can be better today than it was yesterday. And in order to do that, having this design time feedback and deterministic results, because now we're not seeing if this is actually going to induce scalability or not. We know that if we prescribe this constraint, and if it's followed, and if the organization, the teams, and the environment is capable of following it, these are the results we can expect. We brought the variables into the equation instead of hiding them off and then measuring after the fact. One of the things this model tries to accomplish is fit practices over best practices, because there are no best practices in software architecture. But there are practices that fit better, that are a better fit or worse fit. We want to understand the trade-offs, and our success depends on being able to understand the impact to the business, the product, the team, the environment, and the organization. And so we're always managing trade-offs. The thing is, we're never going to design a perfect architecture. And if somebody says they found one, my advice is run, don't walk away from that project, because bad things are going to happen. But we want to find that fit. We define that architecture as an architectural style. This is a big part of this model. It reintroduces this concept, And it addresses challenges like semantic diffusion, which is a term coined by Martin Fowler, who was one of the original signatories of the Agile Manifesto. And he has firsthand experience of how you come up with a label for something, and maybe it's a really meaningful label in the beginning, but as it goes through this game of telephone, through the enterprise, everybody who raised your hand, whatever you're calling Agile is probably, almost certainly, far removed from what the Agile Manifesto was talking about. And so Martin Fowler realized that early on, and he coined this term semantic diffusion. So this way, if you say we're all doing microservices, everybody's like, oh, I understand microservices, got it, because I built microservices my last job. And they're going to bring all these assumptions with them to that project. But when you have your own named coordinated set of architectural constraints, this is something new. And that's going to bypass a lot of the familiarity bias that it's like, oh, I know what this is, and actually causes people to pay attention again and think and have meaningful conversations instead of assuming, oh, I already know all of this. So to wrap all this up, it's a model that allows us to think more holistically about software architecture in a way that is not only going to deliver the needed abilities, it's compatible with the team, the environment, the organization. It talks about these hidden variables that we have to be aware of, the non-technical factors that are going to be crucial to success. And it's going to highlight the risks right away before you build this thing and find out it's not actually going to fit. We're going to see that right away. So beyond that, once you start thinking about architecture as the composition of constraints, this whole idea of, oh, there's n number of architecture patterns and we're going to pick one of those, you start to see there's an entire multifaceted continuum of possibilities. And we can evolve architectures more easily. And I think later this week, tomorrow or Thursday, I'm going to be talking about agile architecture. I'm going to show how this model allows you to deliver true architectural agility. It's because we can evolve the architecture now by modifying or adding or removing constraints at design time or modernization time. And it encourages us to design enough instead of a lot. So the other things that I think are really important in this model and really valuable is that we can give clear documentation, communication, and there's clear ceremonies and processes to get that organizational alignment, because architecture mastery also involves relationship building, influencing, collaboration, communication, things like that. So in the last 30 seconds that we have, the summary of this model, and again, it's an open source model. You don't have to buy the book, or you can reach out to me and I'll send you whatever you need. Micheal Carducci, I'm on LinkedIn. I'm the holistic software architect. I might have a slide. I'm not sure if I have the QR code, but please connect with me on LinkedIn. My email is michael@magician.codes. But we've got tools. We can get deterministic solutions. Instead of building it and seeing if it works or not, we can actually get the results we expect the first time and every time. And these tools equip you for strategic influence, effective execution, and organizational success. So when we look at this, the model itself is simple, but reality is always complex. So it's simple, but it's not easy. And I know we're out of time, but I just wanted to give you a quick overview of this set of ideas. I want to move some unknown unknowns into your known unknowns. And I want to give you some things to think about as you progress through your journey as software architects. And my goal here is to support you in any way that I can. And so with that, I will say thank you.